Negative 4. So x will be equal to negative 4. So you got the value of x is 1 and you got the value of x is negative 4. That means there are two values which are satisfying this absolute value equation. Can you plug in the value of x is negative 4 in the above equation and see whether this works, whether you get 5? Can you plug in negative 4 in the left side?
So wherever it says x, like next to 12.
Correct. It's not 12, it's absolute value, right? It's absolute value.
Wherever it says absolute value and then it says 2 and this says x. So take away x and then you put 5 there. No, not 5. You put 1 there.
You put 1 there. Yeah, we have put in 1 there. And
now we have to do negative 4.
Correct. Yeah.
So 2 and then parentheses negative 4 plus equals 5 and then solve.
Yeah, we'll take the left side of the equation and we'll solve it and we should get 5.
So 2 times negative 4, this would be negative 8, correct?
Yes, right.
Plus 3. Negative 8 plus isn't that 5?
Negative 8, right? So you can use the number line.
I meant negative 5.
Right, negative 5, correct. So absolute value of negative 5, how much would that be? Absolute value of anything, any negative number?
I don't understand what you're asking.
What will be now the absolute value of negative 5? What?
It's 1 and negative 4. Right?
So
no,
you got the answer. You got the answers as 1 and negative 4. That's right. But if in the question you got now you reach to the point where you have to calculate the absolute value of negative 5, how much will be absolute value of negative 5? As I told you here on the right side, any negative number which is in the absolute value, you have to write it as positive. Absolute value of negative 5 is 5. Absolute value of negative 1 is 1. Absolute value of negative 3 is 3. Absolute value of any negative number is that positive number.
Oh, I see. So
your voice is breaking.
It's 4.
Absolute value of negative 5. How much will it be?
4.
You have to just drop negative number. That's it.
So it would be 4, right? Did I get it right?
Can you see the number? What is the number here?
So it's 5.
So why will you get 4? Because you have to just drop the negative number. That's it. Absolute value of negative 5. You have to just drop this negative and keep 5 as it is, and that is the answer.
Oh, so it's separate from the other thing that says x equals negative 4.
That was the answer which you got. X equals negative 4 and x equals 1. But we were just checking whether these answers are correct or not. We were just checking. We don't need this. See, we don't need this below value, below thing. We just need these two numbers, x equals 1 and x equals negative 4, which you were able to calculate. But I was just checking whether 1 is working in this equation or not, and whether negative 4 is working in this equation or not. I plugged in 1, I got 5, so it's working. I plugged in negative 4, I again got 5, so it's working. Because I should get 5 in this equation, as 5 is on the right side. Let us do one more example. It'll become a little more clear. So I'll write the question. I don't know, it stopped working. Okay, absolute value of x minus 3 equals 6. Absolute value of x minus 3 equals 6, and you have to calculate the value of x as we were doing it in the equation. So what you will do, the first step for the absolute value in absolute value equation, what you'll do,
Just separate it.
you will make the two equations, right? So what will be the first equation?
The first equation is x minus 3 equals 6, and the second one is x minus 3 equals negative 6.
Wonderful, great. Now can you calculate the value of x in both equations?
Oh, and you said that the absolute value of x minus 3 is 6, right? That's
Yes.
how you.
Yes.
Okay, so add 3 to
Mhm.
negative 3 and 6, and 3 will cancel, equals 9.
Mhm. And in the second equation?
Add 3 and then add 3 negative 6. So that would be negative 3.
Correct, yeah. So these are the two answers, that's it. X equals 9 and x equals negative 3, that's it. We don't need to go further. So the two numbers are satisfying this absolute value equation. One is x equals 9, and the other one is x equals negative 3. Because when you plug in x equals 9 in this absolute value equation, you will get 6. And when you'll plug in x equals negative 3 in this absolute value equation, you will still get 6 for both the numbers.
I see.
So one more example that you will do yourself. So absolute value of 3x minus 9 equals 6. Give me two x values for this absolute value equation.
3x minus 9 equals 3x minus 9 equals negative 6.
Correct. So can you solve both of them?
On the left, it will be 5, and on the right, it will be 1.
That is the right answer. 5 and 1. You're 100% right. So you got the value of x is 5 and you got the x value of x is 1. That is 100% true. So you have done absolute value equations, and now you'll be able to solve these equations. But now we are going to do absolute value inequalities. That means you're not having an equality sign, you're having inequality sign. As we did inequality. We did, for example, 2x plus 3 is greater than 5. How do you solve it?
This Didn't you say whenever you multiply, you have to change the sign? So I think that you solve this normally.
Yes, whenever
You said
you multiply negative number, you will change the inequality direction. That's right.
so
But
2x
multiplying, yeah,
and then subtract 3 from 5.
okay.
Well,
So you'll, how
something
much?
about, you said whenever you multiply
Yeah, right. So we're subtracting. We don't need to change the sign. We don't need to change the direction.
equals 2, I mean greater than 2.
Yes, and then
Divide greater is greater than 1.
right. So x is greater than 1. So this is the answer to the inequality. Now let us go to absolute value inequality. How do we solve that? For example, you're having 2x plus 3 in absolute value that is greater than 5. Greater, right? So you're having a greater sign. Greater. I have deliberately written OR capital because whenever you're having a greater than sign, you have to make two inequalities. You have to make two inequalities. One will be 2x plus 3 is greater than 5. Other one will be 2x plus 3 is greater than negative 5. Exactly same as absolute value equation. Exactly same. 2x plus 3 is greater than 5. 2x plus 3 is greater than negative 5. But whether we have to write and or in between them, 2x plus 3 is greater than 5 and 2x plus 3 is greater than negative 5, or 2x plus 3 is greater than negative 5. This, for that, we can remember if it is greater or, that means you're having or in between. If there's a greater than sign, you're writing 2x plus 3 is greater than 5 or 2x plus 3 is greater than negative 5. Are you following? So
Yeah.
whenever you're having greater than or greater than equal to inequality, absolute value inequality, you will again make two inequalities. One will be same, 2x plus 3 is greater than 5. Another one will be 2x plus 3 is greater than negative 5, as we did for equations. But there'll be or in between them. So the values which you will get on the left and right side, you have to write or in between them. X is greater than something, or X is greater than something else. Let's try to solve these two. Did you got it till now? What to do for greater
Yes.
than inequality?
You have to choose one at the end.
You you can have, options. Either X is this much or X is that much. That's it. Right? So you can have or in between them. So either X is this thing or X is that thing. So but you
How
will
do you
keep,
know?
then you will see the question. According to the question, you will be able to analyze like which answer I have to take.
Okay, so subtract 3 on the left and then 5. So 2x is greater than 2. Then divide 2. So is greater than 1.
Right.
Side, you should subtract 3 and then cancel and then subtract 3, and this would be negative 8.
Correct.
So divide 2 and then divide 2 on the other side, which would be negative 4.
So you're getting X is greater than 1 or X is greater than negative 4. But we have done one mistake. That is it. One mistake we have done, I mean to say I have done, that we need to rectify. And that is when you're writing the two inequalities, that is 2x plus 3 is greater than 5, or 2x plus 3 is less than -5. That is the mistake which I did. 2x plus 3 is greater than 5, or 2x plus 3 is less than -5. These are the two things which we have to write. 2x plus 3 is greater than 5, or 2x plus 3 is less than -5.
So I think the answer would be, so the absolute value is 5, right? So do you go based off of that, or what x is equal to? I mean, what x is greater than or less than 2?
X is greater than 1, or x is less than -4.
Are these both the answers?
Yes, this will be the answers, but x ranges from, x is greater than 1. So if you see the number line, you're having 0, 1, 2, 3, 4. You're having -1, -2, -3, -4, and so on. So it is telling you for this inequality, which is absolute value of 2x plus 3 is greater than 5, you're having either x as greater than 1. So starting from 1 with a hollow circle, not a solid one, because if this would have been greater than equal to, then I could have made the solid circle, which is including 1. But it is x is greater than 1. So I can't say that x is also equal to 1. X has to be greater than 1. So if x has to be greater than 1, I will make a hollow circle on 1. And I'm going towards right or left. X is greater than 1.
To the right.
Correct. So it'll be like this. So these will be the answers for this inequality. X is greater than 1, or x is less than -4. So let us see where -4 is. It's here, but again, a hollow circle, right? And less than -4. Should I go to the left or right?
To the right.
-4, less than -4, right? So
I guess to the right.
So if you're going to the right, you are going to the bigger numbers. -3 is bigger than -4. -2 is bigger than -4. But it's telling you x has to be less than -4.
That's what I said the first time. It goes to the left, right?
Yeah, it goes to the left, correct.
Thinking.
So these are the answers to this inequality. Everything starting from 1 towards positive infinity, and starting from -4, excluding -4, towards negative infinity, to the left, to the right. And these numbers which are in between from -4 to 1, they are not the answers to this inequality.
Is this what you would write for the answer? Like whenever the answer asks you,
Yes.
Like when there's multiple choice, this is how.
Most of the times they will give you both.
So like if I bubbled it in, I would bubble in the 1 and the -4, or I would bubble in the picture of the number line.
They will not give you only 1 and -4. They'll give you if whether x is greater than 1, x is greater than -1, x is less than 4, x is greater than 1, or x is less than -4. This will be the option 1, for example.
I understand what you're saying.
And the second thing will be, for example, x is greater than -1 and x is less than -4. Third option will be x is less than 4, or x is less than 2, -2. In the same way, there will be 4 options. or 4 or 5 options. So and the first one will be the answer. X is greater than 1 or X is less than -4. There'll be or in between because we are using greater inequality, greater than inequality.
Got it.
So whenever you want to convert the greater than inequality, absolute value inequality, you have to use again, you have to make again 2 inequalities, and one will be the same, 2x plus 3 is greater than 5. Another one will be 2x plus 3 is less than -5. So you are changing the sign also, and you are changing the direction also for the second inequality. You are changing the sign also. From 5 you are changing to -5, and you are changing the direction also. From greater than you are changing to less than, and you're keeping or in between them. We'll do one example. Three x minus 3, absolute value of 3x minus 3 is greater than or equal to -2, -3, for example, -3. So absolute value of 3x minus 3 is greater than or equal to -3. So please tell me what to do now here. Greater, right?
Or equal.
Yeah, greater than or equal. But you will use the rules for greater than inequality as you did before. It doesn't matter. Equal to doesn't matter. It'll, it'll remain there.
The first equation is 3x minus 2 is greater than or equal to -3.
3x minus 3 is greater than or equal to -3, right?
Is that correct?
Yes, yes. And
Is x minus 2, oh, 3, it says 3, is greater than or equal to, no, it would be less than or equal to, right?
Change the
And
sign.
then +3?
Yeah, change the sign, exactly. If you're having -3, change it to +3. If you have +3, change it to -3.
So
what will be in
subtract
between? What will be in between? Or and?
or.
Exactly. Now what it will do?
Oh, add 3. Add 3. And then
Right.
it cancels. Add 3 on the other side.
Three x is greater than or equal to? How much is -3 plus 3?
0.
Correct.
Right?
Yes.
And then on the other side, add 3. And then add 3, which is 6. And by 3 to get 2.
All right. So you got one value as one inequality as x is less than or equal to 2. What will be the inequality here? 3x is greater than or equal to 0. Can you solve it further? How do you eliminate this 3, which is in multiplication with x?
Right? Divide by 3.
Dividing by 3, correct.
Other side as well. That's 0.
Correct. So you got the two values, you got the two inequalities. X is greater than or equal to 0 or x is less than or equal to 2. Beautiful. So now we can use the number line. For example, you're having a 0 here, 1, 2, 3, and so on, -1, -2, -3, and so on. So it's telling you x is greater than or equal to 0. So I'll reach to 0. Will I make a solid circle or a hollow circle?
It'll be a solid.
Exactly. Should I move to the right or to the left?
To the right.
Right, correct. And what about x is less than or equal to 2? If I'll reach to 2,
It will be to the left
correct.
and close.
Closed circle, correct. So now we're having the answers as, starting from 0 till 2. That is it. This is the portion which satisfies this inequality. Others are not the answer. Either x is greater than or equal to 0 or x is less than or equal to 2. So x includes, numbers from 0 to 2 only. So x is greater than or equal to 2. Oh, sorry, greater than or equal to 0, and x is less than or equal to 2. So I can write it in short like this. I have put in x in between, and I have written x is greater than or equal to 0, and x is less than or equal to 2. So this is another way of writing this or this together. X is greater than or equal to 0 or x is less than or equal to 2. I can write it like this. X is greater than or equal to 0 or x is less than or equal to 2. Is it okay?
Yeah, makes sense.
So this was greater than inequality. Now let us go to less than inequality. And we are done with the inequality and absolute value inequality. Let's take an example. 3x minus 2 absolute value is less than 4. Now, less than inequality, greater than inequality, less than inequality, less than, right? AN, try to use and at the end. So you will get and. That means when you will make the two inequalities, same two inequalities, you will keep and in between these two inequalities. So when you had greater than or greater than equal to inequality, you were using or in between. But if you're having less than or less than equal to inequality, you will use and in between.
Right.
Now, can you tell me what will be the two inequalities?
3x minus 2 is less than 4, and 3x minus 2 is greater than 4.
But changing the sign also.
-4.
Right, as you did before. Changing the sign as well as direction. But in between and, whenever you're having less than inequality, you will use and in between. Now, can you solve it?
Add 2.
Mm-hmm.
So x is less than 6.
Correct.
And on the other side, 3 is greater than -2.
Correct, yeah.
And then divide by 3, which is x is less than 2.
Mm-hmm.
And on the other side, that cannot be divided, correct? Right?
Yeah, but it'll be x is greater than -2/3, right? Am I right?
Right. Right.
So I got the two values. I got two inequalities. Either x is less than 2 or x is greater than -2/3. So I can try to make it on the number line to make it more clear. So x is less than 2. So when I will start at 2, should I make a hollow circle or a solid circle?
Hollow.
Right. Towards left or right?
Left.
Correct. Towards left. So I'm making a hollow circle towards left. And x is greater than -2/3. So -2/3, how much will it be? Approximately. Can you calculate it on the calculator?
-6.
How much? Negative
Or
point, -0.666, right?
yeah.
So it'll be nearly, I think here. So you'll again make a hollow circle, sorry. And then it's greater than -0.666. So should I move to the left or right?
Left.
Greater than?
Yeah, left, right?
Greater than means, right? Bigger numbers, right?
Left.
Left
I mean,
is,
you know, I said left, but I knew greater is going to be right. But I really did think right. I'm not lying.
oh yeah, beautiful. Okay, great. Why you should lie? Why should lie? You have to tell me clearly anything, any confusion, anywhere, you feel
Yeah,
the difficulty. So
thinking right, said left, but I knew in my head it was right.
I
So
believe it. I believe it.
um,
I'm having trust. I believe it. So that is the answer. So x is less than 2 and x is greater than -2/3. So and you're having and in between. And why there's and? Because there's less than inequality or less than equal to inequality. And if you're having greater than inequality or greater than equal to inequality, you will put or in between. Right?
right.
There are many questions which are related with this on page number 150, 158. I mean to say 150. Yeah, 150, 159, 159. So try to see the questions which are on which are here on page 159, 160. Try to solve them, as because it'll be more practicing. When you'll do more practice, when you'll do solving the questions, then you'll be able to grasp it more strongly, more firmly. So you're already having the questions there in the book, so try to do them. Now let's move to the next concept, that is
I get
sequences. You have to go a little fast as your exams are approaching, so we'll not go much detail, and we don't need right now. We can have different types of sequences. Number, for example, you're having 3 and then you're adding, for example, 4 to it. It'll be 7, and then again adding 4 to it, it'll be 11. Again adding 4 to it, it'll be 15. Again adding 4 to it, it'll be 19. Again adding 4 to it, it'll be 23, and so on. So you're having a sequence of numbers whose difference is common. You know, consecutive numbers difference is common. 7 minus 3 is 4, 11 minus 7 is 4, 15 minus 11 is 4, 19 minus 15 is 4, 23 minus 19 is 4. So those sequences whose difference is common is called arithmetic sequence. Very simple. Those sequences whose difference is common, when you'll check, you know, consecutive numbers, for example, 15 and 19, you will see the difference as 4. You will check 19 and 23, you will see the difference as 4. You will check 7 and 11, you will see the difference as 4. So wherever there is, you know, same difference, where is common, where they are having common difference, that is called arithmetic sequence. Okay.
Okay.
And in case of arithmetic sequence, the first term which you're having is obviously called the first term. No problem in that. It's called first term, and it's represented by A. Or you can say A1. That means the first term is 3. If I want to say A2, that means the second term is 7. If I want to know A3, that means the third term is 11. Are you understanding what I'm trying to write?
A1 was 3.
A1 is
Did you
3, yes.
understand?
And what about A6?
23.
4, 5. Correct. So A6 is 23. And what is the common difference between them? 3, 7, 11, 23.
They're going up by 4.
So you write D is 4. D is called the common difference. So common difference is 4. And whenever you're having n, you know, nth term means a general, you know, 6th term, 7th term, 5th term, 4th term. So if you don't know the 6th term, you can even calculate the 6th term by using the formula. 6th term is equal to first term plus 6th term, 6 minus 1 times the common difference. See what I'm writing. This is the general form. You know, this is the equation. I mean to say, this is the formula for calculating any nth term, maybe 6th term, maybe 9th term, maybe 20th term, maybe 15th term. Let us write it in general. Nth term is equal to always first term plus n minus 1 times common difference. This you have to remember. Nth term is equal to the first term plus n minus 1 times the common difference. So if I want to calculate the 6th term, I will write 6th term is equal to first term plus n minus 1, where n is 6 for my 6th term. N will be 10 for my 10th term. N will be 20th for my 20 for my 20th term. So I want to calculate the 6th term. So it'll be 6 minus 1 times the common difference, and that is 4. And A1 is how much? What is the first term?
3.
So I can write 3 here. So can you solve it? This one, 3 plus in parentheses 6 minus 1, and then multiplied by 4. How much will it be?
What was the one? The one was
One is the formula one. It's not like anything. It will always be there.
Okay. 3 plus, so first do 3 times 6, and that's
It's
18.
not in multiplication.
No,
it's not in multiplication, right? It's not in multiplication. It's addition, right? So whatever is in parentheses first, you have to do that. PEMDAS.
Okay. Oh, wait, 6 to, so 6 minus 1 is 5. And then 5 plus 3 is 8. Right? And
PEMDAS,
then,
again PEMDAS. Again PEMDAS. You're having
oh,
parentheses and you have done that. You're having exponents? No. You're having multiplication and division, whichever comes first.
that's 4. Okay, so 5 times 4 is 20. And then 20 plus 3 is 23.
Yes, so we got the right answer, 23, and we were knowing that 6 term is 23.
Yeah.
So let us do again this thing. 1 or 2 examples. If we want to calculate 17th term, A17, it's called 17th term. So what will be the formula for A17? A17, that means 17th term, will be equal to first term, that is A1, plus 17 minus 1 times the common difference.
So A1 is 3.
Always,
So
yeah.
and then plus 17 1, so 16, and then times 4 the common difference. So 16 times 4, I don't know, I'm gonna calculate. 64,
Mhm.
and 64 plus 3 is 67.
So 17th term is 67. Got it?
Got it.
So that is how will you calculate the nth term? And if you're given in the sequence that nth term is 8, so it's not given this sequence. There is some more other sequence, but the question is telling you if nth term is 8 and first term is 2, which term is it? Like, and okay, if nth term, no, let us take it as this thing. If fourth term is 8 and the first term is 2, what is the common difference between the sequence numbers? If the fourth term is 8,
Oh, that's the 4.
yeah, A4, sorry. If the fourth term is 8 and the first term is 2, how you have to calculate the common difference, D. So you'll again use the formula. AN is equal to A1 plus N minus 1 times D. And we are given A4. So I'll write A4 is equal to A1 plus 4 minus 1 times D, right?
Isn't it 2? But you have to do it in the formula.
Which one is 2?
2, right? It increases by 2 each time.
Correct. Yes, that's right. That's right. So if you're able to get that, then you don't need to use the formula. But if sometimes you're having those sequences where you're not getting it, in your head, so that means you can use the formula and calculate it. So fourth term will be 8, first term will be 2 plus 4 minus 1 is 3 times D. So you can solve it. 8 is equal to 2 plus 3D. Can you solve it? 8 is equal to 2 plus 3 times D, and you have to calculate the D, the common difference.
Okay, so this is a different formula, right? So
it's not a different formula. It's not a different formula. It's the same formula, but now the different unknown is there. That's D. We were calculating AN, but now we are calculating D.
Before the formula was A1 and now it's A4 in the beginning, right?
Before, the formula was AN in general, right? AN equals A1 plus N minus 1 times D. A4 is equal to A1 plus 4 minus 1 times D. A6 is equal to A1 plus 6 minus 1 times D, as we did it before. So it depends on what you're having. You're having A4, you're having A1, and you want to calculate the common difference D. So you will use the general formula an is equal to a1 plus n minus 1 times d, and you are given a4, so why not to use fourth term is equal to first term plus 4 minus 1 times d, this one. Where you're facing confusion?
I'm not anymore.
So fourth term is 8 is equal to first term is 2 plus 4 minus 1 is 3 times d. And then I can subtract 2 to both sides. I'll get 6 equals 3 times d. I can divide by 3 to both sides. I'll get 2 is equal to d, or d is equal to 2. That is the common difference which you told me.
Yep, makes sense now. More clear.
Great. So this is the sequence. Can I just give you the introduction of geometric sequence?
Mhm.
All right, so let's go to geometric sequence. See, right now we saw the sequence which was having the common difference. Now let us see one more sequence. Let us see one more sequence. You're having 2, 4, 8, 16, 32, 64, and so on. Is it having common difference everywhere? Difference common?
No, it increases each time.
So that means it's not an arithmetic sequence, right? So if it's not having the common difference, it's not an arithmetic sequence. Now let us see, is it increasing by some multiplying factor? For example,
Yeah.
see 4
By
divided by
2.
2, how much will it be?
Multiplied by 2 each time.
Correct. So let us see the ratio. 4 divided by 2 is 2, 8 divided by 4 is 2, 16 divided by 8 is 2, 32 divided by 16 is 2, 64 divided by 32 is 2. So there is common ratio here. In the arithmetic sequence, we were having common difference, but in this sequence, we're having common ratio. So wherever there is common ratio, you will be having this sequence as geometric sequence, right? So wherever there is
Right.
common ratio, you'll be having that as geometric sequence. That is called geometric sequence. So so geometric sequence includes common ratio, and common ratio is called R. So you can write R is equal to 2. And again, you're having the first term A1 here as 2. And the formula for calculating the nth term is simple. See, I'll show it to you. An is equal to A1 times R raised power n minus 1. An is equal to A1 times R raised power n minus 1. So this is the formula for calculating the nth term. Let us calculate. This is the first term, this is the second term, this is the third term, this is the fourth term, fifth term, sixth term. Let's calculate the sixth term. A6 is equal to A1 times R raised power n minus 1. For calculating this, what?
What does R stand for?
Common ratio, as I told you, common ratio.
Okay.
Second number divided by the first, third number divided by the second, fourth number
So you
divided
have
by
to first, like in the last type of arithmetic sequence, you didn't what D was, like the how much it was increasing. So do you have to know how much it's increasing this time? Like, do you have to know what R is?
Correct. Yes. How much the R is? How much will be the R in this sequence?
It would be times 2 to the
Right.
power of 2.
It'll be 2. Just simply 2, because R means common ratio. Common ratio means, you know, a second number divided by the first, third number divided by the second, fourth number divided by the third, fifth number divided by the fourth, sixth number divided by the fifth. So you're always getting 2.
Do I have to know this beforehand to solve it?
If other things are given, then you need to know this if you're having the sequence, right?
Like before I plug everything into the equation, I need to know what R is?
Yes.
Or I can
Yes,
here.
right. You're right. Before plugging in, you know, before using the equation, you need to know what R is.
Okay.
So let us calculate sixth term. A6 is equal to A1, that is the first term. How much is first term?
2.
2 times, how much is R?
2.
2 raised to the power n minus 1. Which term we are calculating?
A.
Like which one? Sixth one, fifth one, fourth one? A6, right? We're calculating the sixth term, isn't it?
Yeah.
So
I
it'll
didn't
be,
see it.
so n will be 6.
Which is 5.
Yes, it'll be 2 times 2 to the 5th power. And 2 times 2 is actually 2 to the 1, right?
Right. So you can, because they're like terms now, so you can multiply them.
If you're having same bases in multiplication, what you will do to the powers?
You add them. So this is going to be 6.
Correct. So the sixth term is 2 to the 6th power. Can you calculate how much is 2 to the 6th power? You can use the calculator also.
I'm not sure how to do it on the calculator, actually. I think I can just do 2 times 2 times 2 times.
Okay.
I don't know
okay.
how, like, to make it do it shortly and easily. I don't know, like, the button that's like the squared. I don't know where the squared button is. So I always do 2 times
2 times 2
2
times
times.
2 times 2 times 2.
Right.
That means you need to, you know, enhance your calculator skills also, because they'll be very handy for you in your examinations. So my calculator is hanged. So I'll use the simple calculator. You might be able to see this here. Uh-oh. So you're having 2 to the 6th power, but this calculator is not having this much. 2 to the 6th power is 64. I did it.
Which button did you push?
It is x to the y. So I put in, you know, here x to the y. For example, 2 to what power? I just mark this. So which power? 6. 2 to the 6 is equal to 64. But this calculator is different. You need to use your own calculator. You need to see the tutorials of that calculator.
Yeah, I'm gonna look that. Mine.
Is it TI-84, TI-83? Oh, it's TI-83, right?
Actually, I'm using a simpler one now because that one got stuck. Whenever we were trying to do the thing yesterday, I button and now it's stuck on something. So I don't know how to get rid of it. I'm gonna watch a tutorial for that.
You can check that also on the internet, that how to reset it.
Yeah, I cannot use that calculator like for the upcoming until I fix it.
Just search for how to reset TI-83. That's it, and they'll give you the instructions on the
Good
YouTube.
idea.
Okay, so one more question and we can stop if you want. So we'll be having
But we can keep going. Like, I'm learning a lot.
Okay, great. So it's 27 and you're having, and so on. 3, 27, and so on. You don't know after this. So you know just the first term, that is A1, is 3. How much will be the common ratio? You need just the two terms. It is given that this is geometric sequence. Hello?
Can you show me again the
Yeah,
whole thing?
yeah, I'm just writing one more question. Geometric sequence, I'm writing the geometric sequence as 3, 27, and so on, right? So this is the geometric sequence, and because of this, I know that the first term is A1, that's 3, and how much will be the common ratio?
9.
9, correct? Can you calculate the fifth term? Formula, you need to remember the formula.
For the first part of the formula where it's a(n), is it just a times n, or is it a to
No,
the
it's
power?
a subscript n, right? It's just the notation. It's just the notation an.
What does subscript?
Subscript means it's just the name, you know. Superscript, subscript, you know. On the top you're writing somewhere name, and on the bottom you're writing some name.
So what will the subscript do?
It is just denoting you which term you are interested.
So here, wait, you said which term do we put there? Like which term?
A5, A5.
5. Yeah, so put a subscript 5.
Mhm.
It's
First of,
equal to
mhm.
a1, which is 3. So it's equal to 3. Oh,
Mhm.
a sub. Okay, I understand. Plus and minus 1. So for this one, it's not n actually, right? It's r, and r was 9.
Yes.
So it would be 9 minus 1, which is 8. And
Mm,
then equal to, no, not equal to, and then multiplied by d. So what's d?
there are
Is
there are
not
two sequences, right? One is arithmetic, another is geometric, right?
right. So I leave that out. Okay, I can redo it.
Okay, so we're interested in geometric sequence right now, and we have to use the formula for a geometric sequence. I have written the two formulas. The first formula is for arithmetic sequence, and the second formula is for a geometric sequence.
Okay, I'm gonna redo it. A r, so a sub. What would for a? I know that r is 9.
R is 9. So which formula you're using? First, you can tell me like which formula you're using.
You said that's ar equals a1 minus r to the power of n minus 1. It says ar, right? Or does it say
an, right?
a?
Nth term, ninth term, 10th term, nth term, you know. An is equal to a1 times r to the n minus 1. So an, we are interested in a5, that's fifth term. So
Right.
a5, so n will be 5. A5 will be equal to A1 times R to the 5 minus 1.
Times? I thought this was minus. Oh, that's a times. Okay.
So A1 times R to the n minus 1, right? So A5 will be how much? Fifth term will be how much? A5 is equal to A1 times R to the 5 minus 1. A5 is equal to A1 times R to the 5 minus 1. So A5 is equal to A1. A1 is 3 times R to the 5 minus 1 is 9 to the 5 minus 1.
5 minus 1 is 4, so change it to 4.
Yes, 9 to the 4th power. 3 times 9 to the 4th power. But if you'll not be having this as answer, you know, option A, option B, option C,
Yeah.
option D, option E. If you're having 3 to the 4, second option is 3 to the 9, third option is 3 to the 8, fourth option is 9 to the 4, fifth option is 3 squared times 9 to the 6th.
I know that 3 would be 3 to the 1, and then add 1 to 4 is 5.
But
And
you're
then
not
add 3.
having same bases, right? You're not
Oh,
having same bases. You're having 3 and 9. So can you convert 9 to 3?
yes. Divide it by 3.
No, you cannot divide. Like, can you represent 9 in terms of 3? Isn't
I'm not
9?
sure.
Okay, what about this? What about 3 squared? How much is 3 squared?
No.
What?
9.
So can I write, instead of 9, can I write 3 squared to the 4th power?
Yeah, I wouldn't have thought to do that though. So I think I need more practice with this because like I would have thought of that.
Mhm. Yeah, that's right. Because this is actually tough thought for the first time when a person does these types of questions, as you know, we are actually doing from the scratch. That's why. Otherwise, these things, you know, would have been there in your practice before, but as we are doing from scratch, so it'll be happening in the, you know, in the first instance, and then you will get it. You will be able to solve the questions when these types of questions will come again. You will get that intuition that how to convert this 9 in terms of 3. So 9 is actually 3 squared. So I have written 9 as 3 squared whole to the 4th power. Now when power is raised to the power, what you will do to the powers?
Add them. No. Multiply them.
Yes, you have to multiply them. So 2 times 4.
8.
So A5 is equal to 3 times 3 to the 8. Now you're having same basis. Now you can do what you were saying.
This
Voice is cutting, breaking.
6 to the power of 9.
When you're having same basis, keep the base same. Always remember, keep the
Oh,
base same and add the powers. So which option will it be? When you're having same bases, keep the base same and add the powers in multiplication. When you're having same bases, keep the base same and subtract the powers in division.
I see.
So it'll be 3 to the 9th power, right?
Right.
So this was geometric sequence. These two formulas, you need to remember them by heart. This an is equal to a1 times r to the n minus 1, and an is equal to a1 plus n minus 1 times d. Above one is for arithmetic sequence, and the below one is for geometric sequence. Right? Are you getting it?
I'm getting it. I'm just, the part I'm not getting is whenever you did the parentheses and then you converted the 9 to a 3 to the power of 2, and then you did 4 on the outside. I don't understand that. I mean, I do understand you did it, but I just would not have
Yeah, you did understood the process, but you didn't get that yourself like before.
yeah, I didn't get it myself. I didn't
Yeah.
think
Mhm.
that.
Yeah, that will happen, you know. The more practice we do, the more we get it. The more we get it, you know, the more we'll be familiar with the questions and the ways and the, you know, tricks and, you know, strategies and everything. The more we'll be acquainted with all these things. As I told you that we are doing from the scratch, that, you know, these things should have happened before in maybe in ninth grade or 10th grade, but we are doing it today. So that's why you might feel a little bit, you know, new things going on, but this is just for the once, you know. As I told you that I converted 9 into 3 squared. Now if this situation will come to you, you will definitely be able to do it yourself. For example, if you'll be having 2 times 4 to the 5th power, what you will do here? 2 times 4 to the 5th power. Think about it.
Change 2 to 2 to the second power.
Right, change 4 to 2 to the second power. So you got it now. So 2 times 2 squared to the 5th power. And how much is power raised to the power? What you will do to the powers?
Multiply them.
So 2 times 2 to the 10. So how much will it be?
Two to the 11.
Right, so that's it, you did it. Previously you did 2 mistakes. I mean, say you were not able to get this, how to convert 9 into 3, and then you were not able to multiply the exponents. You multiply the bases also. You edit the bases, but that was not the case. So now you didn't do that mistake again. You are done now. If this type of question will come, I believe 99.99% that you will not do the same mistake again. You are done with it now. You can convert now any number to any other number, provided that is, you know, the power of that number, and you can, you know, get the answer as you did it right now. So you'll definitely be acquainted with this, and now you'll not be stuck with this type of problem.
I think so.
I believe so. So this was about sequences, and after that we're having systems of equations. So systems of equations. Systems of equations is nothing but equations, but not one equation, 2 equations, or in higher classes it will be 3 equations or 4 equations or 5 equations. That is called systems of equations and nothing else. Right? So as you did equation, solution to the equation, the same thing is to be done with systems of equations. For example, you did y equals mx plus b, y equals mx plus b, or you're having equation y equals 2x plus 3, and you were able to know that 2 is the slope, which is the coefficient of x, and 3 is the y-intercept. which is when the graph cuts the y-axis. Now, if I tell you if y equals 2x plus 3, and one more equation, one more line is y equals negative 3x plus 4, can you solve these two systems of equations? So what we can do here is we can, we can plug in the value of y from equation 1 to the value of y to the y in equation 2. See, before we were solving only one equation. For example, 2x plus 3 equals 0. We were solving this for x. We were subtracting 3 to both sides and then dividing by 2 to both sides. We got x equals negative 3 divided by 2. And this was solving an equation, one equation. Now, if you're having two equations, y equals 2x plus 3, y equals negative 3x plus 4, you can also solve them. How? Just put in the value of y from one equation to another equation. If y equals 2x plus 3, then can't you plug in the value of y as 2x plus 3 in the second equation? So when you will do it, you will get the answer. So plugging in the value of y as 2x plus 3 in second equation, you will get, instead of y, I'll write 2x plus 3 equals negative 3x plus 4, and then I can solve it. I will keep all the variables on the left side and all the numbers on the right side. I will first subtract 3 to both sides. I will get 2x equals negative 3x plus 1. And then I will add 3x to both sides. I will get 5x equals 1, and then I will divide by 5 to both sides. I will get x equals 1 over 5. So I have solved for x. I have got the value of x is 1 over 5. Now I need to calculate the value of y also in systems of equations, because we're having two variables, two unknowns. So I will plug in the value of x as 1/5 in one of the two equations. It doesn't matter in which equation you put in. You can put it in first one or the second one. Let us put it in the first one. Y equals 2 times x is 1 over 5 plus 3, or y equals 2 times 1 over 5, that means 2 over 1 times 1 over 5. A fraction is multiplied with a fraction, so you can multiply 2 with the 1 and you can multiply 1 with the 5. That's 2 over 5 plus 3. And then you have to keep the denominator same in order to add the fractions, as we discussed previously, few sessions before. So I will also keep, 3 is having 1 in the denominator. I want to keep it 5, so I'll multiply it with 5 and divide it with 5. So I will get 2 over 5 plus 15 over 5. And I
I'm
will
not
get,
following that part.
okay, this addition part.
Yeah, I was following the top, and then the second line I wasn't following anything.
Right, so till x equals 1 over 5, you
Following that.
okay, and after plugging in the value of x is 1 over 5, did you get that? How I plugged in the value of x is 1 over 5 in one of the equations?
No, don't get that.
All right, 1 second. So see, you're having two equations, y equals 2x plus 3 and y equals negative 3x plus 4. I plugged in the value of y as 2x plus 3 in the second equation. I got the value of x as 1 over 5, isn't it?
Mhm.
So x is 1 over 5. Now you can plug the value of x as 1 over 5 in one of the two equations, in either equation 1 or equation 2, whatever you feel feasible. Any equation you can plug in, you will get the value of y same. So which one you want to plug in, first one or second one?
The first one.
All right, so I have written the same thing. The first equation, y equals 2 times x plus 3.
Oh, okay. So the x 1/5, is that the answer, or you will get the answer once you plug it in?
That is one of the answers, because we're having two answers here, because we're having two unknowns here, right? If I want to select two persons from the class, then I need two names, right? So that is the case for the systems of equations. Systems of equations are having the unknowns as y as well as x. So you got the value of x, you are done 50%, right?
Right.
You got the value of x, you're 50% done. Now you need one more person, which you have to select for some cultural event or something. So so the second person is y, and y depends on x, right? Y is equal to 2 times x plus 3, or y is equal to -3 times x plus 4. So y depends on x. So I will plug in the value of x in y in the equation 1 or 2. I will get y also. I'll get both the persons which I need for some cultural event. You know what I'm trying to talk about? Like, so what I'm doing is I'm plugging in the value of x is 1/5 in equation 1. We will do it
Why
in
did you
equation.
do 2/1?
Why did I?
Why did you do 2/1 whenever you're plugging in the equation? Like, the original is 2. Why did you do over 1 for the new version?
Oh, okay. Because whenever you're having any number, for example, 3, isn't 3 as 3/1? No difference at
Yeah.
all, right? So in order to make you understand, I wrote 1 in the denominator
So
so that,
normally I wouldn't do
huh?
so I can't. Normally, if people are solving it, do they have to write the over
No,
1 or
no. ACT doesn't care about your writing, neither your working. They just care about like your options. Yeah, your which option you are plugging in. So whether you write it here or you don't write it, or you keep it in you solve it in your head, they don't care at all, right? But in order to make you understand, I wrote this so that you will be able to recapitulate the multiplying of fractions. For example, 2/3 times 3/5. So you'll go 2 times 3 is 6, divided by 3 times 5 is 15. So that's why I wrote 1 in the denominator, to make it a little more clearer. 2 times 1 is 2, and 1 times 5 is 5. Otherwise, we don't need to write it, right?
I see. Mhm.
So I can write it as y equals 2 times x plus 3, and we got the value of x is 1/5. So we can simply multiply 2 times 1/5. How much will it be?
2/5.
Right, 2/5 plus 3. Now, if you have to add the fractions, what it will do with 3?
Over 1.
All right, and then because you need to have the same
5.
denominators.
Right. So the least common multiple,
Right,
I don't think there is any.
least
Oh,
common
5.
multiple for 5 and 1 will be 5, isn't it?
It's 5.
So that's why
And
I'll
so,
multiply 5 to the second fraction to make it 5 in the denominator. No?
yeah, so 1 times 5. I didn't know that, but I know it now. 1 times 5 is 5, and then 3 times 5 is 15.
So I got this as the fraction, 2/5 plus 15/5. How much will it be?
17/5.
And that is y. Oh, sorry, 17/5. This is y. So you got both the persons selected. Now you're done. Your job is done. X is 1/5 and y is 17/5. And these are the two answers for x and y for the systems of equations, right? Because
Right.
systems of equations are containing two variables, x and y. There are two unknowns. So you got the value of x as 1/5 and you got the value of y as 17/5. So you're done.
Follow me.
Now, I want to show it to you on the graph what this really means. X equals 1 over 5 and y equals 17 over 5. Remember it, write it somewhere.
Right, what?
Write the values of x is 1 over 5 and the value of y is 17 over 5 is somewhere in your rough on one side, because I want to open the graphing calculator.
Y equals 17 over 5?
Yes, y equals 17 over 5 and x equals 1 over 5. And write the two equations which I have written here. Y equals 2x plus 3 and y equals negative 3x plus 4. Done?
No.
Okay.
Is that a 3 or a 2?
First one is y equals 2x plus 3 and the second one is y equals negative 3x plus 4.
Okay, I wrote it.
So as you know that y equals 2x plus 3 is a line actually, and y equals negative 3x plus 4 is also a line. Now let us graph these lines on the graphing calculator. Can you tell me the lines? Y equals?
Y equals 2x plus 3.
2x
And a
plus
y.
3. Okay, I have made y equals 2x plus 3. And second line?
Y equals negative 3x plus 4.
Negative 3x plus 4. So I have made one more line, negative 3x plus 4. That's blue line. The red line is y equals 2x plus 3. And what do you mean by y equals 2x plus 3? What does this 2 denote? Always
The
this, yeah.
x-axis
The 2 denotes the slope, right? Always.
and slope.
And 3 denotes what? Where this
The
line cuts the
x.
y-axis. Where this line cuts the y-axis. You see, the red line is cutting the y-axis at 3.
Oh, right.
So the red line is cutting the y-axis at 3, right?
Right.
And what about this negative 3x plus 4? What is this negative 3?
The negative 3 is the slope
And 4?
where it cuts the y.
Correct. So we have made the two lines and we have got the, we are having two lines and they are intersecting each other. They're crossing each other at a point. Are you able to see that point, black point?
I see it.
What are the coordinates of this point?
0, 2, 3, 4.
0.2. Okay, it's 0.2, 3.4.
Oh, I see. I had to zoom in to see that.
Okay.
I thought it because it was small.
Now tell me what were the solution for your two equations? What was x and y for your two equations? What you got?
Over 5.
Mm-hmm.
Y was 17 over 5.
Can you calculate 1 over 5 on the calculator in decimals? Your voice is breaking.
0.2.
And what about y?
0.4.
So are you able to see anything common?
Same.
Hmm?
Yeah, it's the same.
It's the same. That means when you're solving two equations, systems of equations, you are getting the coordinates of that point where the lines intersect each other. You got the value of x as 0.2 and the value of y as 3.4. That means you're getting the coordinates of the point where the lines are crossing each other.
I see.
You're getting?
Getting.
So whenever you have two lines intersecting each other, you will be having x coordinate and y coordinate of that, right? You'll be getting that.
Right.
But tell me, if you're having two parallel lines, y equals 2x plus 3 and y equals 2x plus 6, for example, these two lines, they are parallel lines. I will make it first. I'll make them first. Y equals 2x plus 3 and y equals, y equals 2x plus 3 and y equals 2x plus 6. So we got two parallel lines because they are having the same slope. When you're having the same slope, that means the lines will be parallel, isn't it?
Yes.
So when you're having two parallel lines, will they intersect each other?
No.
Will you get the value of x or y something?
Yeah.
So x and y means that
Oh,
point where
so
they intersect.
you only get the y.
Exactly. No, you will not even get you will get the y-intercept, but you will not get that coordinate where these two lines intersect each other.
Mm-hmm. And so you said that you can identify the parallel from the equation?
Yes, definitely. You're gonna identify the parallel lines from the equation by seeing the slope.
So this is no solution?
Exactly. Wonderful.
If
This
they're the
is
same slope, it's no solution always?
correct. At least it's, they'll be having no solution because they're having the same slope. They will not cut each other, so they will not be having any solution. They will not be, intersecting at some point. They are just strangers. They have not met anywhere,
Yes.
And if you're having two lines, they are one on each other, like they are coincident. I'll just write it. 2x plus 3 and 2x plus 3. Both the lines are together, like they are exactly on each other. Doesn't that mean they are meeting at every point?
Yes. So is that infinite solutions?
Exactly, that is infinite solution. So you have read it somewhere, right?
Well, I remember taking a test where it says like no solutions, infinite solutions. I
And
did
one
very bad.
solution. Okay,
Like I didn't know the meaning, but I've seen it.
now you have seen the meaning, right?
Yeah, now I understand what it means.
Wonderful, great. This makes me happy. So infinite solutions, yeah?
Oh, I said it makes me happy too because I was struggling.
Yeah. So infinite solutions, no solution, and one solution. Infinite solutions when the two lines are exactly on each other. No solution when the two lines are parallel. One solution when the two lines are intersecting each other, having different slopes. Right?
Right.
So this is how can you analyze whether you're having infinite, no, or one solution. So if you're having the solution, whether infinite or one, those equations are called consistent. If you're having the solution, whether it is one solution or infinite solutions, those equations are called consistent equations. And if you're having no solution, they are inconsistent. Very straightforward. No solution, they're inconsistent. Some solution may be one or infinite, they're consistent. Right?
Right.
So we got the systems of equations. We can solve the systems of equations by plugging in the value of y or x from one equation to another equation. We will get one value, and then we can plug in that value. We'll get another value. Those two values, the x value and the y value, will be the intersection of the two lines. And you will be getting the x and y value when the two lines are having different slopes. You will not be getting the x and y value when the two lines are parallel, right?
Right.
You will not be getting that because they are not intersecting. And the equations which are having solution, maybe one or infinite, they are consistent. And if having that equation where there's no solution, they are inconsistent.
Right.
So this was about systems of equations. So we're doing good, I think. We're just doing 2 months, 3 months, 1 month's course in like in one portion of an hour. Like,
Which is good. I understand it.
yeah, that's great. Understanding it is important. So if this would have been given to you before, then you would have been flying right now.
Yes, for should have gotten lessons from you sooner, but I didn't know about fiber or anything.
Mhm. All right, so this was systems of equations, and now we'll do with the logarithms, and then we'll stop. Before going for logarithms, we are having exponents, as we have done. What is 2 to the third power?
8.
8, exactly. And exponents, the opposite of exponents is logarithms. Is, you know, see how I'll write logarithms. Log of 3 to the base, I'll just think about it. Log of 8, one second, log of 8 to the base 2 is equal to 3. This means, see, log is having one number which is in front of it, big one, and there's a subscript number which is at the bottom, 2, very small number. So log means what can be raised to this base number to get 8? What can be raised to this base number? What power can be raised to 2 to get 8?
4.
What power can be raised to 2 to get 8?
3.
3. So that's why log of 8 to the base 2 is 3.
Makes sense.
Let's do one more example. Log of 16 to the base 2. What number can be raised, what power can be raised to 2 to get 16?
No. 4.
4,
No.
correct. 4 is the right answer. 2 to the 4 is 16. See, it's one and the same thing. 2 to the 4 is 16. Log of 16 to the base 2 is 4. It is just the opposite way, you know, very similar. Log and exponent. Okay, one more. What power can be raised to 1,000? Sorry, what power can be raised to 10 to get 1,000? 10 times 10 times 10.
So 3.
3, so 10 cubes. So it's 3. Right? So What power can be raised to 10,000? Oh, sorry, 10 to get 10,000.
4.
Right. So log of 1,000 to the base 10 is 3, and log of 10,000 to the base 10 is 4. How much is log of 9 to the base 3?
3.
3.
No, 2.
2, because 3 times 3 is 9. So 3 squared is 9. So 2. So we have to raise power 2 to 3 to get 9. Now, if the question is, if log 9 is 2 to the base x, it's given. Now there is 2 here. What is x? What is base? Which base, when raised to a power 2, will get 9?
Three.
3, correct. So you can decode it. You can write it in this form. Since log of 9 to the to the base x is 2, that means you can say that x to the 2 power is 9, and then you can see which value satisfies this x. It is 3. 3 squared is 9. So x is 3. Right?
Wait, 3. I thought it would be like is equal to 3.
Where? Can you repeat again, because your voice is breaking?
Oh, no, I get it.
Okay. So if the question is log of 100 is equal to 2, log of x, log of 100 to the base x is equal to 2, what is x?
10.
10, correct. Or else you can write it as x squared is equal to 100, or you can write 10 squared is equal to 100, so x is 10. As you told me, x is 10. So this is log and nothing else. So you can convert always, you can convert log into exponents and exponents into log. So log of 32 to the base 2 is how much? Log of
16.
16. Does that mean 2 to the 16 is 32?
Oh. 15. No. 17.
That means you're raising the power 17 to 2 to get 32, right?
So this is, what is the question?
Log of 32 to the base 2 is how much? So what power needs to be raised to 2 to get 32? How much is log of 32
8.
to the base 2?
It's 8.
2 to the 8th power? Are you sure? 2 times 2 times 2 times 2 times 2 times 2 times 2
Or
is
4.
2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So 2 to the 4 is 16. 2 to the 5 is 32.
Yeah, I didn't know that.
Well, we could always do it, right? 2 to the 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. So you're writing 2 5 times.
Is there any on the calculator?
Yes, yes, you can do the log on the calculator also.
No, to find the what? So you know how you did 2 times 2 times 2 times 2 to find out what is the power? Like, is there a way to calculator?
Yes, you
Or
can do it on the calculator, but TI 83 you can do that. In TI 83 you can do that.
can you do it on yours so I can see?
I'm just checking it on my local calculator. I don't think it'll be here. Standard scientific graphing. Mm, I'm having log here. You know, when you're having log, it means that they have kept the basis 10. For example, log of 1000 will be 3. Log of 1000 will be 3. I'll just do it here. See, log of 1000, log of 1000 is 3. See that? Because
Yes.
whenever it's written log only, that means there is a base of 10. All right. So in TI 83, you can change the base also. You don't need to go 2 times 2 times 2 times 2. You can change the base also. So, and there's one more log, that's ln, ln. That's also log, but its base is e, and e is equal to 2.714. So the base is e for ln, and the base is 10 for log. But I need to do it on the TI 83. You can easily calculate log of 32 to the base 2 on the calculator. You will write log of 32 and 2. You can change the base, you can write the number, you will get 5 as the answer. You can get anything, whatever you want in terms of log, but you should be able to at least convert log to exponent. That's what needs to be done. For example, log of 125 to the base 5 is how much? What do you mean by this? Log of 125 to the base 5. That means what power should we raise to 5 to get 125?
I don't know the number.
You can always do it on the calculator. 5 times 5 times 5 and so on till you get 125. So can you go on doing it? How much?
I'm doing it right now.
Okay.
3.
3. So log of 125 to the base 5 is 3. Now you need to also, convert this into, exponent form. So you'll write it as 5 to the 3 is 125. Isn't it?
Yes.
So you should be able to convert, log to exponent and exponent to log. Very simple. Just try to see this again after our session or maybe before our next session, so that it'll be more clearer to you how to convert the log into exponent, and exponent into log. All right.
Right. So for tomorrow's session, is okay, or 8 p.m.
What time?
10 a.m. or 8 p.m.
10 a.m. or 8 p.m. for tomorrow. 1 second, I'm just checking it. It's Wednesday. 10:30. Yes,
No,
we
not
can. What?
10:30. Also, so I can do a 1 hour session at 10 a.m. or at 8 p.m. a little bit longer. But if it's at 10 a.m., it has to be exactly 1 hour. It can't be any longer. And if it's at 8 p.m., it can be a little bit longer.
I can do it at both the times. I mean to say, 1 second. But no, not 8 p.m. tomorrow because I'm already having a scheduled session tomorrow for 8 p.m. So can we go for 10 a.m.
Yeah,
tomorrow?
10 a.m. is
All right, so tomorrow 10 a.m. I'm writing it. Okay.
okay. Thanks for this lesson so much. This was a very productive lesson.
Thank you. Thanks a lot.
I'll see you tomorrow.
Okay.
Thank you. Have a good night or a day.
Okay, thank you very much. You also. Bye-bye.